Good evening. So this is the day 3 of our daily physics practice, uh, right? So up to now we have completed two questions. So this is the plan. So daily we'll be discussing an MCQ question just to revise what we have learned so far, to revise the theory content through questions, right? So this is our plan. So alhamdulillah, we have completed two MCQs. So this is the third one, right? So as usual, we'll follow the basics, right? When we find a question, what should we do? First, we should read it carefully. Second one, we should arrange the informations in an order. And third one, we should analyze the question on how we can apply and what are the laws we can apply, what are the equations we can apply, and what are the concepts we can apply here, right? This is the steps. These are the steps, right? Okay, now let's read this question and get into the working. A small block is placed on a top of a prism like wedge that is on a smooth horizontal surface as shown in the figure. The mass of the wedge, the mass of the wedge is very large compared to the mass. The mass of the wedge is very large compared to the mass of the block. The system is moving right, with a constant velocity of v. The height of the block is h, and the velocity is 2gh, square root 2gh. If the block is slowly allowed to move, what will be the speed of the block when it reaches the horizontal surface? So what is the scenario? They're saying initially the system, the wedge and the block moves with a velocity v, right? And they are saying that velocity is square root 2gh itself. Now they are saying, what if the block is allowed to move independently? That is the scenario, right? And they are saying if it is allowed, what is the velocity when the block reaches the horizontal surface? What is the velocity of the block when it reaches the edge of this surface? That is the question. Okay, let's see, how we can get into this question. So let's see what are the now this is how I'm approaching the question. Now, if there are students who are now only starting to get used to the questions, right? First, analyze the question and what we can apply here. Now can you see there is height involved, there is velocity involved, so eventually they are connecting some sort of energy here. So we can apply concepts. If I write it as concepts, we can apply energy conservation, energy conservation theory, right? So mainly here they have mentioned about energy conservation, and let's see. No, if we just analyze the question, we can identify that there is some sort of energy conservation related here. So after that, when we are doing the workings, let's see, are there any new things that we can apply, right? Okay. Now we know that the block is at this point. So when the system is moving at velocity v, there is something we should know. This block is also moving with a velocity v. Don't forget that. If a system is moving, now just think, I am a skater. I am moving. This was a past paper question. I am a skater. I am having a helmet, right? I am a skater. So not a skater. I'm a rider, right? I'm a bicycle rider and I am having a small helmet. Now I am riding with a velocity of 10 meters per second. This helmet would also have that same velocity, right? Okay, so this is having an initial velocity of v, and now you can just have some sort of idea that this would have an initial kinetic energy plus a potential energy. Why? Because it is at a height of h, so it has a kinetic energy and a potential energy. And when it comes to this part, what is the energy it has? There is no potential energy. Why? Because this end, this is the grounded surface, the ground surface, right? So there is no height from here, right? So here is only kinetic energy. So normally there is something called yeah, here it is moving. Right now we have analyzed the energy part. Okay, let's write total energy initial equals to total energy final. You might ask, sir, how? Because there is a conservation there. This is a conservation theory. You might ask, sir, there is mentioned that conservation theory. See here, there is no loss in kinetic energy, which means there is no loss in energy, right? And they have also said that, yeah, there is no loss in kinetic energy. So this is a completely, we can apply the total, energy conservation theory. Okay, what is the total energies that are present initially? We have kinetic energy. Kinetic energy is represented by half mv square plus gravitational potential energy mgh equals to, finally we have only kinetic energy, so half mv, we don't know the new one, so I'll mention it as vx square, right? So all three have m in common, right? So I can cancel the m as all of these have m, right? Okay. Now they have mentioned that v is equal to square root 2gh. So v square means it is equal to 2gh divided by 2 plus gh equals to half vx square, right? So I can cancel these two also. How? See here, 2 cancels off, right? So it will be gh plus gh equals to vx square over 2. So gh equals 2gh, right? That 2gh plus, no, I'll write, right, 2gh and vx square over 2, right? I can take this 2 here, right? How will it look like? So now 2gh into 2 equals 4gh equals vx square, right? Vx square. Okay, what now? This is first equation, right? What is the value of v, which is the initial velocity? Initial velocity was v square equals 2gh, right? This is the second equation, right? To find a relationship, I'll divide the first equation by the second equation, where I'll get vx over v2. Sorry, vx over v, right? There is no v2. Wait. Vx over v, complete thing square, 4gh divided by 2gh, right? Let's cancel off gh common, right? 2 here, 4 there are two twos, right? Okay, now what I can do, I can bring this square into this side. Square, if I move to the other side, it will be square root, right? So it will be looking like vx equals to v square root. Now you have got an answer. What normal student will think is, right? Let's see. Is there any answer? Square root 2. Yeah, sir, this is the answer. And some might go and say, this is the answer. No. If you see, actually, this is not the answer. Now, if you see, there is a pattern in questions, right? Now, if you read, normally after the 40th question, the last 10 would be complex type of question. No, I'm not saying they're hard. There will be some sort of questions where they are testing or they're playing with some words. They won't be giving a single information without a purpose, right? Most of the time they will be giving a statement. Each and every statement would have a meaning, which means they would have a contribution in the question. If you see here, there is a point which seems like there is no involvement in the question, but there is an involvement. Let's see let's see it again. A small block is placed on the top of wedge, and now this explains the arrangement. The mass of the wedge is very large compared to the mass of the block. Now, did we consider the mass of the wedge here? No. Now, but still they're saying the mass of the wedge. The mass here, let's take it as capital M. Now let's take the mass of the block as simple M. They are saying capital M is very, very large compared to simple M, it seems. Why should they inform that for us? If you think carefully, what happens here is I'll draw the structure again here, right? This is what happens actually, right? This is the wedge part, right? And if you see, the block is here, and when it comes here, right, when it's moving here, right, when it's moving here, can you see there is a reaction force that is created? Why they're touching, right? Normally they are touching. Yeah, they are touching. Let's see, I'll draw it here, with another color, that would help you to understand, right? Right, okay. Now see here, this is touching, so there would be a reaction force here, there would be a reaction force here, no doubt about that. Okay. Now here the weight would act in this direction. The weight would act in the direction. If there is an angle in the wedge, theta, right? If you see, there would be an sine angle this side. Why? It will be looking like this. Theta, here also theta, right? Here will be mg cos theta, and here will be mg sine theta. Now, if mg sine theta is in this direction, there would be a there would be a reaction force in this direction also. There is a force that is exerted by the block to the wedge, right? I'll mark it as F. This is the force that is exerted by the block to the wedge. Ah, okay. You might ask, fine, but still, what is the change that happens? If you see, they are saying the block moves downwards, so the block will be exerting a small force here, F, when it's moving. Why? Because it has to, balance this mg sine theta, right? It is pushing this force, right? And this is balanced by the mg sine theta. But as so they are cancelled, right? We don't want to consider. We can cancel it if they are similar forces, right? But the problem is, if you see here, they are saying the mass of the wedge is very, very large compared to the simple limb. So just think the force that is exerted by the wedge onto the block, will it be very, very greater? Will it be greater compared to the F? Yes, it will be greater. Why? Because this mass, capital M, and if you consider this mass, simple M, capital M is greater compared to simple M. So, if even if this block exert this force, that is comparatively negligible. Yeah, we can agree. But still, can you see there is a force that is exerted? There is a change that is taking place, right? Right. So, in order to balance that, now if you see, there's a small force for a large mass. So opposite of that is, for a small mass there would be a large force. Clearly try to understand that. So this is a large mass. They have said the capital M is very, very large than compared to the simple limb. So for a large mass, they're exerting a small force. Why? There's a small mass. The small mass exerts a small force. So opposite of that or similar to that is, for a small mass there is a greater force. Now see, if there is a force, greater force that is created, can you understand there the velocity of it would increase? Why, you might ask, why the velocity increases? Why means, if you see F equals ma, right? When the force increases, the acceleration would increase. If the acceleration increases, what happens to the velocity? What happens to the change in velocity? The velocity would increase. So the velocity starts increasing, right? You might feel, okay sir, you are saying it is increasing, but how can we find actual velocity? Here the examiner gives you a, gives a trump card. Now he says, if you have that idea enough, you have the answer. What is the idea? We theoretically found that the velocity should be v into square root 2, right? V into square root 2. But we didn't consider this force scenario. If the force scenario also is being considered, what is the final point, or what is the final conclusion we come to? If we consider this force theory also, we can say that actually the velocity would be slightly greater. Why? Because there is an extra force that is exerted. When the force is exerted, there's an acceleration, which means there's an increase in the velocity, which means the actual velocity of this object vx should be slightly, or it should be greater than v square root 2. Can you understand why? Because theoretically we found it that Vx is equal to V square root 2. But due to this force we considered, we can say that it is not actually equal. There is slightly, it is greater. Sorry. I have marked the opposite direction, right? Sorry. Don't confuse. Right? Right. Actually, we can say that it is slightly greater. Vx is greater. Vx is greater than v square root 2. What is the answer? More than square root 2, we have only one answer. What is that? 2v. That is the answer. Can you understand? No, I'm sure that almost 90% of the students might have got until this point this answer. But we should understand that these points are the ones that make students lose the point, but lose the mark, right? If we consider this, Can you understand? There is a force that is created due to that force, right? Due to that force, there is an acceleration, that there is an increase in velocity that is created, which means compared to the actual velocity, the real velocity would be slightly greater. Theoretically, this is the velocity, but actually, if you see, when we consider these forces, the velocity would be slightly greater than the theoretical value. Ah, that value is only, we have only one such value. What is it? 2v. There is no, this is not an essay question. We no need to prove it. If we have that idea, this is the answer, right? I hope you got some sort of knowledge from this, right? So let's see, right? This is the working, right? Okay, so try this question, right? I hope you got some sort of concepts. Don't worry, right? You might, some students might have, got it wrong. No worries, right? Gently, slowly, let's start. Let's make our brains get used to the pattern of questions they ask, right? So don't worry if you have got it wrong, right? If you have got it correct, very good, right? If you have got it wrong, no need to worry, right? This is the first steps, right? The first steps would be bit harder. Don't worry, right? Gently we'll make it practice. And this is the day 3, right? Normally it will, when you pass almost a month, right, you will feel there is an improvement. And after a month, if you try this question, you can easily get this question, right? Okay, thank you.